Hello everyone, my name is Breno Macedo Faria. I'm a civil engineer and concrete technical director of ANAPRE. ANAPRE is a concrete flooring and coating association in Brazil. Also, I am a technical manager of LPE Engenharia. LPE is an engineering office specialized in design of industrial floors and pavements with many projects executed in Brazil and other countries. This presentation aims to show the successful project carried out at the International Airport in Fortaleza, Brazil, and the challenges faced and overcome by the team involved on this work. Let's start with some building data. Pavement in concrete for international aircrafts. This chart shows the kind of aircraft that will operating over the pavement. The area of the pavement is 37,000 square meters, and the engineering works, design and detail, start from August 2020 until November 2020. The execution of first phase, 15,000 square meters, starting on December 2020 until January 2021. And the starting operation over the pavement, over the first phase, starting 1st February 2021. The project consumed these materials: concrete, 11,000 of cubic meters, microfibers, 66 tons, and steel, 160 tons. The team involved on the project is LPE Engenharia, that designed the pavement, CBC, Construtora Batista Cavalcante, the contractor, Fraport, the consortium, Cimento Apodi, the concrete supplier, and Comaro, the flooring finisher. The pavement structure. Based on the aircraft and terrain characteristics, the first design suggests a concrete pavement as following: a plain concrete with thickness 41 centimeters, and the maximum distance between joints 5 meters. Using microfibers, we could optimize the solution, get the following sections with 31 centimeters of thickness and the maximum distance between joints 8 meters, 6% higher than the original solution. It brought more economy during the construction, less maintenance with joints, and more durability. Take into consideration this defined section, we detail everything on the pavement: the subgrade and the subbase characteristics, the distribution and detail of each joint, the saw-cut joint, the construction joints, the joint with existing concrete pavement, and the joint with asphalt. We detail the concrete characteristics, the localized reinforcement, and the test types and their frequency. To build the pavement, we had to face the following challenges. First, logistics, building a pavement inside the airport operation. And the main challenge was the weather in Fortaleza. With high and constant winds, with speed 10 to 25 kilometers per hour, and the temperature always hot, around 30 and 35 degrees Celsius. The concrete thickness was high, and the microfiber has elevated dosage, 6 kilograms per cubic meters. This increased the risk of crust, the surface, blister, and lamination. To prevent the risk, the team took the following actions. First, analyze the concrete mix design. This chart presents the mix design and his analysis. And the aggregate distribution. And this chart shows the distribution of aggregate and the grade curve of concrete. Then we propose adjusting the concrete aggregate curve, reducing the risk of bleeding, crust of surface, and fibers on surface. After that, we test the performance of the concrete in laboratory, the slump and the loss of slump with time, the set time, bleeding, the resistance and the gain of resistance with time, and the concrete fiber ductility, trying to optimize the fiber dosage. With this test, we propose to adjust the additives and to reduce the time set of the concrete. Visiting the concrete plant, we suggest sprinkling water over the coarse aggregate in order to reduce its temperature. After this test, we've carried out a slab test, a prototype, out of the airport for checking the concrete performance and the team working procedures. With the slab test, we changed the concrete to reduce the interval between initial set time and the final set time. This will reduce the risk related to the surface of fresh concrete exposed for a long time. We executed 4 slab tests until get the best performance of the concrete and the execution. During the construction, we realized that the evaporation rate was high. Evaporation rate depends on wind, the weather temperature, the concrete temperature, and the relative moisture. And with a weather station, we estimated the evaporation rate. It was between 0.6 and 0.7 kilograms per square meter per hour. That is a little bit high. Then we proposed the concrete curing using 3 processes. First, the evaporation retardant to reduce the risk of crust on surface while the concrete is fresh. The chemical cure, objective meeting the performance of cure according to ASTM C309, increasing the surface resistance and reducing the risk of problems with shrinkage. And the wet cure, to reduce the temperature on surface and the risk of microcracking. All these actions that were done allowed the team to build the pavement without problems. No cracks, no delaminations, and no curling. This picture is the pavement during the execution. And this picture is the pavement ready to use. And this picture is the pavement during the operation. The success of this project was mainly due to a highly committed team and their interaction. They had focused on the final results, that lead them to overcome all the challenges and build a pavement with the expected performance. So, I would like to thank the team involved in these projects: LPE, CBC, Construtora Batista Cavalcante, Fraport, Cimentos Apodi, and Comaro. And I would like to thank the institutes associations that allowed these presentations: ACI, ANAPRE, ABESC, and ABCP. Thank you.